Here are some tips to graph exponential or transcendental functions. That just means that the variable is going to be part of the exponent. For us to be able to graph them, the first thing to know is that there is a horizontal asymptote for all exponential functions. Where it's located is at y equals whatever constant value is at the end of the function. Probably where you want to start graphing each of these things is to figure out where that horizontal asymptote will be. It's always at y equals the constant value. The next tip for us to be able to graph these is to remember exponent rules that we learned in algebra. The first of our exponent rules that we need to know is that anything to the 0 power is 1. No matter what you're raising to the 0 power, the result of that is going to be 1 every time. The next rule to remember is that negative exponents create fractions. For example, 2 to the negative 1 means that the base 2 is misplaced. It's on the wrong side of the fraction bar. We need to move it to the other side in order to fix that negative exponent. We should never leave a negative exponent. When you move the 2 across the fraction bar, now 1/2 is the value. Notice though that it is a positive 1/2. The negative in the exponent has no bearing on the sign of the outcome. Positive 1/2 was our value. If we do 2 to the negative 2, that's the same as 1 over 2 squared, which of course would be 1/4. Again, it's a positive value. Then the last thing for us to keep in mind as we graph these exponential functions, since there's not a square root and since there's not a fraction involved with the variable, this means for what we know so far, the domain will be from negative infinity to positive infinity. Now let's look at an example of one. Here I've got 3 to the x power. The variable is in the exponent. The first thing I would want to do is to find where there's a horizontal asymptote. Now for this one, since there's no constant value back at the back, that means y equals 0 will be my horizontal asymptote. We can't see that because it's the x-axis. But notice that our picture is getting very close to that x-axis without crossing over it. Now let's just substitute some things in and see what values we get out. If I take 0 and put it in for x, 3 to the 0 power, anything to the 0 power is 1, so 0, 1 is a point part of our picture. Now if I take positive 1 and put it in, 3 to the first power would make 3. 1, 3 then is a point that is part of our picture. And one more point, let's take negative 1 and put it in. 3 to the negative 1, remember a negative exponent creates a fraction. 3 to the negative 1 is the same as 1/3. It's a positive 1/3, so it's above that x-axis. Here is negative 1 1/3. Our shape for all exponential functions will look like this. Now they can move around where they are, but that's the shape that we'll see on each one of them. The range of this thing, remember it's the lowest y to the highest y. We're getting really close to y equals 0, but we can't quite get there. So our range begins at 0, but it's got parentheses since we're not quite getting down to 0. The lowest y was at 0. There's not a highest y, so 0 to infinity is our range. Let's try a couple more examples of graphing exponential functions. For this next one, our horizontal asymptote, remember, is at y equals the constant. This time I do have a constant value back at the back. So y equals 1. Here goes our horizontal asymptote. We're going to get really close to that, but we're never going to get to touch it. Now if I just substitute a few things in, putting 0 in for x, 3 to the 0, anything to the 0 is 1, so 1 plus 1 made 2. 0, 2, That's one of the points, part of our picture. If you take 1 and put it in, 3 to the first power would make 3, and 3 plus 1 made 4. So 1, 4 would be another point, part of our picture. Now if we take negative 1 and put it in, 3 to the negative 1, that creates a fraction. 3 to the negative 1 is 1/3. 1/3 plus 1 is 1 and 1/3. Notice that's a little bit above our horizontal asymptote, so there is where our picture is going to start. Let's approach the asymptote, not touching it, hit those points that we know, and there is our exponential shape. Notice that this thing is 1 to 1. It passes the vertical line test, which makes it a function, and it passes the horizontal line test, which makes it 1 to 1. This means that our picture would have an inverse function. We'll meet that in a later section. Now, the domain of this, again, was negative infinity to positive infinity because there's no square root and there's no fraction where the x is. Those are the only things we know so far that restricts our domain. Looking at the range, the lowest y is at 1, but we never quite get there. So I've got to have parentheses with the 1. It goes up from there forever, 1 to infinity. Now for our last one, let's notice that the horizontal asymptote is at negative 1. So here goes our horizontal asymptote at y equals negative 1. Horizontal asymptotes are always y equals a number. Now as I go to substitute things in, if we take 0 and put it in for x, remember that exponents happen before multiplication. So forget that the negative's there for a second. 3 to the 0, anything to the 0 is 1. Stick the negative on and you've got negative 1. Now negative 1 minus 1, that's going to give me negative 2. So 0, negative 2 is a y-intercept for this picture. This time we're down below the horizontal asymptote. This is because the negative in front gave us a reflected picture. If I take 1 and put it in, 3 to the first power would be 3. Stick the negative on, you have negative 3. And minus 3 minus 1 gives me negative 4. So 1, negative 4 is down here. You maybe can guess how the picture is already going to look, but if not, go ahead and take one more point and put it in. Negative 1. 3 to the negative 1 created a fraction. 3 to the negative 1 is 1/3. Stick the negative on, you've got negative 1/3, and negative 1/3 minus 1 is negative 1 1/3. So that's about right in here. Now, same shape that we had before, approaching our asymptote, but not quite getting there. And now this time the picture is flipped over due to the negative that was on the front. Notice what our range is going to be this time. The domain was still negative infinity to positive infinity since there's no fraction and no square root, and those are the only things we know of that restrict domain so far. But the range this time, it's the lowest y to the highest y. The lowest y happens out on this side this time. It's going to negative infinity down here. So negative infinity is where our range begins. The highest that we can get, the ceiling that we've got, is at negative 1. We never quite get there, so I'll need parentheses around it. For us to graph something exponential, we always want to first locate the horizontal asymptote. That's at y equals whatever number is back at the back. Then you can just substitute numbers in to be able to find your picture. Some people that are good at shifting things will notice that a +1 moves the picture up by 1. A -1 would, of course, move the picture down by 1. You can also do horizontal shifts, left or right, by putting constant values in the exponent. For me, it's just as easy to just substitute things to figure out where the picture belongs. If you'd like, you can think of shifting or translating these exponential functions as well. Now, remember what happened in the past when we tried to move things? If you put a constant value back at the back, it made for a vertical shift. If you put a constant value inside some grouping symbol, it made for a horizontal shift. We're going to have the same thing happen on these. If we've got a constant at the back, we've got a vertical shift. When we put a +1 at the back of the function, it moves the picture up by 1. Likewise, if you put a -1 at the back of the picture, it'll move the picture down by 1. That's just the same as what we've been doing all semester. But now look at what happens when we want to make a horizontal shift. Since there's not any kind of a grouping symbol present, in order for us to make a horizontal shift, what we'll have to do is to put the constant value in the exponent. Now here, for this one, putting a -1 in the exponent up there with the variable moves us to the right by 1 place. I've put that in all capital letters so that you'll remember a minus sign moves you to the right. That kind of seems backwards, but it's the way that it goes. If we then want to move to the left by 1, we'll put a +1 in the exponent to make that happen. Let's look at an example of how this might be worded. Find the equation when f of x is equal to 3 to the x is translated, that means moved, to the left by 5 and up by 2. Now, of course, if we're going to take 3 to the x and move it, that's what we want to start with. Now, to make it move left by 5, this is a horizontal shift. It's part of the exponent. Left is a plus sign. So left by 5, we need +5 in the exponent. Now to make us go up by 2, up, that's going to be a constant value back at the back. So up by 2, we need to add 2 at the back. +2 made us move up by 2 places.